Hello, viewers. In today's session, we are going to discuss some important problems related to inverse trigonometric functions. And in this class, we are going to solve these four problems related to the principal value branch of secant inverse function. So, let us start. So while solving these four important problems, we are also going to use some important results from trigonometry, right? So viewers, we know that the principal value branch of secant inverse function is given by this interval that is the closed interval, that is 0 to pi, excluding this value, that is pi by 2, right? So the principal value branch of secant inverse function, or sometimes we also write arc secant, and the principal value branch belongs to this interval, that is the closed interval 0 to pi, excluding this value, that is pi by 2, right? And the domain of the secant inverse function is given by r minus this interval, that is minus 1 to 1, right? So we can say that the secant inverse function is defined from this set to this set, right? So we have r minus minus 1 to 1 to this interval 0 to pi, excluding this value, that is pi by 2, right? So this set is the domain of this function secant inverse, and this set gives us the range of secant inverse function, right? And moreover, we'll also utilize this important definition, that is secant inverse of secant theta is equal to theta whenever this theta belongs to this interval, right? So we have 0 to pi, and excluding pi by 2. So this result is going to play an important role while solving these four problems. So let us take these problems one by one. So in the first problem, we have secant inverse secant 9 pi by 5. So if we compare this expression with this one, that is secant inverse secant theta, then the value of theta is 9 pi by 5, right? And this value is in radians. So let us convert it into degrees. So we can see that this is 9 by 5 multiplied 180 degrees, and if we solve this expression, we get 324 degrees, right? And 324 degrees is obviously outside this interval, that is 0 to pi, that is 0 to 180 degrees, right? So we have to first split this term, that is 9 pi by 5, like this, that is we'll write 9 pi by 5 as 2 pi minus pi by 5. So now we can write this expression equal to secant inverse, and we can write secant 2 pi minus pi by 5, because 5 times 2 is 10, and 10 pi minus pi is 9 pi by 5, right? Okay, so now here we have secant 2 pi minus pi by 5, and we know that secant 2 pi minus x is equal to secant x. So we have secant inverse, and secant x is pi by 5. So here we have pi by 5, right? Now this expression is similar to this one, right? And the value of theta is now pi by 5, and pi by 5 is obviously equal to 36 degrees, and 36 degrees, it lies within this interval, that is 0 to pi, right? So from this result, secant inverse secant theta is equal to theta. So here we have pi by 5. So the value of this expression is equal to pi over 5. So now consider this problem. Here we have secant inverse secant 5 pi by 4, and this expression is similar to this one, secant inverse secant theta, and the value of theta is 5 pi by 4, right? So we cannot write this expression equal to 5 pi by 4 because 5 pi by 4 is equal to 225 degrees. This is in radians and this is in degrees, and here we have utilized the fact that pi radians is equal to 180 degrees, right? So 225, it lies outside this interval, that is 0 to pi, that is 0 to 180 degrees, because this result is valid only when theta belongs to this interval, that is 0 to pi, except theta is pi by 2, right? So what we will do, will again split this 5 pi by 4 like this, that is we can write pi plus pi by 4, that is 4 pi plus pi is 5 pi, right? So now this expression can be written as secant inverse, and then we have secant, and then we can write pi plus pi by 4, right? So the purpose of splitting 9 pi by 5 as 2 pi minus pi by 5, and 5 pi by 4 as pi plus pi by 4 is to get this form, such that this angle theta belongs to this interval, that is 0 to pi, except pi by 2, right? Now here we have this form, that is secant pi plus x, right? And secant pi plus x is equal to a negative of secant x. So these results are from simple trigonometry, and now we can write secant inverse, and here we have negative of secant pi by 4, right? Okay, now here we'll again make use of one important result or important property of secant inverse function, and the property goes like this, that is secant inverse of minus x is given by pi minus secant inverse x, right? Now here for x we have this entire quantity, right? So this is secant inverse negative of x, and x is secant pi by 4. So here we can now write this expression using this result. We have pi minus secant inverse x, and our x is secant, that is secant pi by 4, right? So we can now write pi minus, and secant inverse secant pi by 4 is simply a pi by 4, because this quantity is similar to this one. Secant inverse secant theta is equal to theta, provided theta belongs to this interval 0 to pi, and here theta is pi by 4, and pi by 4 is obviously 45 degrees. 45 degrees, it lies within this interval, right? So now we have pi minus pi by 4. So this is 4 pi minus pi over 4, that is 3 pi by 4, right? And 3 pi by 4, it lies in this interval, that is 0 to pi minus, that is excluding pi by 2. So the value of this expression is equal to 3 pi by 4. So now consider this one. Here we have secant inverse secant minus 7 pi by 3. right? So here we'll first make use of another important result from trigonometry, that is secant minus x is equal to a positive secant x. So here we have secant negative of 7 pi by 3, so we can simply write secant inverse, and then we have secant 7 pi by 3, right? Using this result, secant negative x is equal to positive secant x. Now see, this expression is again similar to this one, and if we look at this expression, then theta is 7 pi by 3. So this is 7 times 7 over 3 times 180 degrees, and this is 7 times 60, and this is 420 degrees, and 420 degrees it falls outside this interval, that is 0 to 180 degrees, right? So again we have to split 7 pi by 3. So we can now write secant inverse, and we have secant 7 pi by 3 can be written as 2 pi plus pi by 3, because 3 times 2 is 6, 6 plus 6 pi plus pi is 7 pi by 3, right? Now here we have this form, that is secant 2 pi plus x, right? This is 2 pi plus x, and again from trigonometry we know that secant 2 pi plus x is simply secant x. So we have secant inverse and secant pi by 3, because x is pi by 3, right? And now this expression is similar to this one, secant inverse secant theta, and the value of theta is now pi by 3. This is 60 degrees, and this pi by 3, it obviously belongs to this interval, that is 0 to pi minus pi by 2, right? And this expression due to this result is simply equal to theta, and theta is pi by 3, so here we have pi by 3. So the value of this expression is pi by 3. So now consider this problem, secant inverse secant of negative of 8 pi by 3. So again following the similar steps as we have in problem number 3. So we have secant minus 8 pi by 3, and due to this result we can now write secant inverse and simply secant 8 pi by 3, because secant negative x is equal to a positive secant x. And now if we compare this expression with this one, then we can see that theta is 8 pi by 3, and if we convert 8 pi by 3 into degrees, that is pi radians is 180 degrees. So now this is 3 times 60, and this is 8 times 60 is 480 degrees, and 480 degrees it lies outside this interval, that is 0 to pi, that is 0 to 180 degrees. So we have to split this term, that is 8 pi by 3. So we can now write secant inverse, and we have secant 8 pi by 3, and 8 pi by 3 can be written as 2 pi plus 2 pi by 3, because 3 times 2 is 6, so 6 pi plus 2 pi is 8 pi, right? And now we have this form, that is a secant 2 pi plus x, 2 pi plus x, so this is x. So we have secant inverse and secant of simply 2 pi by 3, because secant 2 pi plus x is secant x, right? So now this form is similar to this one, secant inverse secant theta is equal to theta whenever theta belongs to this closed interval 0 to pi excluding pi by 2, and here our theta is now 2 pi by 3, which is equal to 120 degrees, and this value belongs to this interval, that is 0 to pi, and excluding pi by 2. So the value of this expression due to this result is simply 2 pi by 3. So the value of this expression is equal to 2 pi by 3. So viewers, this is how, by making use of the definition of the principal value branch of secant inverse function and some important results from the trigonometry, we can easily evaluate expressions of these kinds.